Assalamu alaikum. I'm Abu Hodara Ridhan. Here is our project demonstration video for EEE 416 Microprocessor and Embedded Systems Laboratory. Our project title is Microcontroller Based Digital Logic IC Tester. Here is the outline of our project presentation. We'll discuss summary, background, methods, perform simulation, and show results. To identify a logic gate, we'll implement digital logic IC tester. We'll develop a method. We'll execute our code in STM32 Cube IDE. And finally, we'll demonstrate results in Proteus. Digital logic IC tester is microcontroller based and it tests the type of logic gate used in the IC. In electronics, testing tool is required to make whole system work. In IC-based works, testing ICs is necessary before using them.
Assalamu alaikum. My name is Mohammad Jain Alam and I'm going to be talking about the methods that we followed during our project. The components that we utilize are STM32, a 14-pin IC or ICs, and an LCD during the simulation. We read the IC outputs during each state of the input provided by the STM, and the readings based off the outputs are evaluated by the STM32, and based on that, LCD shows the IC name. However, if no IC is connected to the ZIF socket, then the LCD will notify us that there is no IC selected or connected. In broad, this is the STM32 and the ZIF socket. The pin 4 and pin 5 of the ZIF socket is provided to inputs, and from the pin 6, the output is sent to the STM32, all of which are pulled down through pull-down resistors. If we signify each of these connections, namely A, B, and out, and provide all the available states possible, we can see the output can have sequences x1, x2, x3, x4 based on the gate. For the gates, the output x1, x2, x3, x4 will be of this form as shown here. Notice that as the NOT gate has only one input, it will be connected to the pin 5. Accordingly, the output shall be 1010. Also, the no IC being pulled down will have the sequence 0000.
I am Fahim Mashur and now I am going to talk about the simulation part of our project. For our project we have used an STM32 microcontroller, STM32F103C86, and for configuring the microcontroller we have used the software STM32 Cube IDE. We configured the pinout and clocks and finally generate code and compile the code to generate a hex file which will be fed into our microprocessor for execution. In the pinout configuration, we set different pins as input and output as required for our project. Firstly, we have the test 0 and test 1 pin set as output, which gives the 2-bit input to the test gates. Then we have the test out pin set as input, which takes the output from the test gate for checking purpose. The D0 to T7 pins are connected to the LCD data pins. The RS and EN pins are set as output and connected to the respective LCD pins. Finally, we have the RCC oscillator input and output pins connected to our external crystal oscillator. Now for the clock configuration, instead of using the internal clock HSI, we have used an high-speed external clock HAC. For that, in the clock configurations, we have to connect the source clock to the HAC and set the input frequency to 8 MHz. Now, in order to drive the LCD using the STM32, we have to include LCD drivers which have been collected from the following source. In the main.c file, in the main function, firstly we initialize the LCD by defining all the data ports of the LCD, and finally creating an LCD object using the LCD create function. We create the LCD in the 8-bit mode. Now this is our main execution loop, which continuously checks the gate using the check gate function, and which returns a string giving the name of the gate type. In order to check the type of the gate, we have defined the output sequences for the given input sequences of different gates. In the check gate function, we give 4 input sequences using the variables test 0 and test 1. Test 0 and test 1 values are written into the test 0 and test 1 pins respectively using the write pin functions. Finally, the output of the test gate is taken into the test out array using the read pin function. from the test out pin. Now the test out variable contains the outputs from the check gates in an array. In order to compare those against the defined output sequences as mentioned before, we convert the array into corresponding integer having the same sequence of ones and zeros. For example, if the array has 0 1 1 0, it is converted to the corresponding integer 1 1 0 using the bin to int function. Now using a simple switch statement, we check the output sequence against the defined output sequences and return the name of the gate. If none of the gates matches, then by default we return an error, and if we get all nulls for all the 4 input sequences, then we return no IC.
Assalamu alaikum, my name is Farhan Fuad. I am going to demonstrate the Proteus part of this project. This is our schematic diagram, and this is STM32-bit Cortex M3 processor, and this is a crystal oscillator whose frequency was set at 8 MHz, but the frequency was divided into 1 MHz in this STM32. And this is our LCD screen where the output will be shown, and here are total 7 logic gates. So let's simulate the Proteus. As none of the logic gates are connected now, our LCD is showing no IC as output. Now if we connect the AND gate, it's showing AND gate. Now let's connect OR gate. So this is showing OR gate. Now if we connect NAND gate, this is showing NAND gate. Now let's connect XOR gate. So this is showing XOR gate. Let's see what happens if we connect NOT gate. So this is showing NOT gate. Now we connect XNOR gate. So this is showing XNOR gate. So we have successfully identified all the logic gates shown here.
This is our PCB layout that we have designed for our project, and this is the 3D rendering of that PCB layout. This part would be in actuality replaced by a ZIF socket if we actually were to design it in hardware. In future, we would like to implement this in hardware and design a PCB for practical use. In conclusion, we would like to thank our course teachers cordially as to being cooperative during our entire course and help us throughout our project work. Assalamu alaikum.